All right, so we talked about how Python provides just a lot of functionality through what we call packages, libraries, and modules. In the last section, we talked about the standard library. So that's all the functionality that comes built into Python or along with the Python installation. And we saw that there's a whole bunch of them. But there's still a lot of functionality not provided by Python. And so different parts of the Python community have kind of worked on, gotten together, collaborated, and built all these other types of packages that just simplify different tasks. So these could be scientific tasks, machine learning tasks, could be for developing web applications or even websites. There's just all different types of functionality. And so third-party packages unlock just a huge range of additional functionality that native Python doesn't provide. And we can access those, if you recall, from PyPI and then also Anaconda. Those are the common places that we would install those third-party packages from. And within the data science or statistical computing side of it, there's a bunch of third-party packages that we will be leveraging throughout this course that just make different things easy. For example, Pandas makes it easy to work with tabular type of data. NumPy provides many different forms of numerical computation. Scikit-learn allows us to do some machine learning modeling. SciPy provides various types of scientific and computing capabilities. Matplotlib provides some plotting, and there's many more that hopefully we'll have a chance to expose you to throughout this course. Now, Jake van der Plas, if you're not familiar with that name, he's been around the Python community for quite a while. He's written some great books, and he's also been a part of creating third-party packages that are very influential. And he had a presentation back in 2017 that talked about the data science ecosystem. And really, he was focused more on the visualization aspect, but he had this great image here that just kind of shows how the data science ecosystem grows within Python. And the way to think about this is we have our core Python down here at the bottom. Then we have a bunch of packages that just make working with Python for the purpose of like statistical computing just easy, simple, and efficient, right? CPython allows us to do a lot of things very fast, right? Very quick computation. NumPy allows us to work with various types of numerical arrays and do different kind of computation with them. Jupyter allows us to have an interface to do some type of statistical computing. Then on top of those tools, we often have other tools that are built. For example, SciPy and Pandas is heavily built on top of NumPy. It leverages this capability. And then as we move even further, such as Scikit-learn. Scikit-learn is a package for machine learning. And that is heavily built on top of Pandas, SciPy, and NumPy. And if we keep going out, we actually get to packages that are built for the purpose of specific domains. For example, AstroPy is a package that is really focused on like astrophysics and statistical computing within that domain. And this package is built on top of packages such as Scikit-learn and stats models, and then Pandas, SciPy, and NumPy. So you can see as the ecosystem grows, right, we have foundational functionality and foundational packages that get built on top of in order to create more advanced capabilities. And this is really the beauty of Python and the ecosystem, is that as these third-party packages grow, right, we continue to be able to build on top of them and create even more capabilities. Now, another great, this one was a blog post, not a presentation, and I linked to this blog post within the lesson for this week. And this has to do with a different way of thinking about the data science landscape. And in it, Paco Nathan, who's a data science researcher, he did a really good job of talking about the ecosystem for specific purposes, like specific like fundamental tasks that we do in scientific computing and what packages are prevalent in those areas. For example, we have for package management, right? We've talked about pip and conda already. For data access, right? We can access data with SQL Alchemy. That's if we are working with the SQL databases. Beautiful Soup is a way to access data that sits within within websites. We have data representation packages such as Pandas and NumPy. Those are packages that allow us to hold numeric data or data that we do for data analysis in a way that makes it easy to work with. And we have packages within the analysis and modeling like scikit-learn, Stats Models, Keras, PyTorch, which those are both deep learning type of packages. So these are all packages focused on actually performing like modeling tasks. And then we have visualization. So I really liked this blog because it allows you to kind of get a grasp of what are some very popular and common packages for different parts of the data analysis or stats computing pipeline. All right, so there are a ton of packages, and the ecosystem within Python just continues to grow at an extremely fast rate. So there's always this challenge of like, how do I keep up? How do I understand the developments that are taking place within the Python ecosystem for statistical computing? And there's a lot of resources that you can leverage. Ones that I have found helpful include the O'Reilly Data newsletter. This is something you can sign up for. And also Python Weekly. So this is a weekly newsletter that gives you updates as to what's going on within the Python ecosystem. There's some podcasts that I really enjoy, two of which are Talk Python to Me and Python Bytes. Now these are not always data science specific, but they do cover a fair amount of data science topics. But they also give you exposure to what are other things, other advancements going on in Python that you may not necessarily think are relevant to you, such as creating applications, right? That may not be something you're thinking about with statistical computing. But in organizations, we often build applications to provide an interface to work with these different statistical computing capabilities that we create, right? So a lot of times you can find some very cool things that you wouldn't think would be relevant to you, but actually can be. And then obviously Google, just spending time researching what are different things you can do in the Python ecosystem. For example, I use Todoist. This is an app that allows me to manage like the things that I want to do, and I can create projects and actually have basically a to-do list in order to accomplish that project. Well, there's a Python API interface that allows me to actually work with that app through Python, right? So it's doing things like that can kind of, on one hand, help you learn Python, but then also just kind of learn cool things that we can do with Python in our everyday life.